Every time cinema shows us a spaceship accelerating to the speed of light, they show us the exact same thing. Stars turning into stretching white lines all around us, while the pilots travel peacefully toward another galaxy. It's a beautiful image, but real physics tells us a completely different story. If you managed to reach 300,000 kilometers per second, you wouldn't witness a majestic journey through the stars. What you would experience is a visual nightmare, a violent distortion of reality, and an almost instantaneous death. Stick around until the end, because you won't believe what would happen. Imagine you are inside a spaceship in deep space. As your ship picks up speed and approaches a significant fraction of the speed of light, the entire universe starts to distort before your eyes due to two inevitable physical phenomena: the Doppler effect and the aberration of light. In daily life, we know the Doppler effect thanks to sound. When an ambulance approaches you, the sound waves compress and the siren sounds higher pitched. When it moves away, the waves stretch out and the sound becomes lower pitched. With light, the exact same thing happens, but on a cosmic scale. As you accelerate, the light waves coming from the stars in front of you get compressed. This shifts their color toward the blue end of the electromagnetic spectrum, but the distortion doesn't end there. Due to the aberration of light, the speed at which you move alters the angle at which photons enter your eyes. Even if there are stars to your sides or even behind you, the extreme speed makes all photons appear to come from straight ahead. The visual result is terrifying. The entire sky, the whole universe surrounding you, would begin to contract into a single, blinding point of light, right in the center of your windshield. Around you, complete darkness. A tunnel of shadows with a single spotlight of extreme radiation at the end. However, contemplating that spectacle for more than a few microseconds would be impossible, because space itself would become your worst enemy. We usually think of outer space as a perfect vacuum, but it isn't. The interstellar medium is filled with gas, helium, and tiny specks of cosmic dust. At normal speeds, these particles are harmless, but kinetic energy drastically depends on velocity. When you travel at 99% of the speed of light, every single hydrogen atom that hits your ship's hull doesn't act like simple gas. It turns into a high-energy projectile equivalent to the radiation produced inside a particle accelerator like the Large Hadron Collider. If you want to know more about the fascinating experiments happening there, don't forget to check out this video. The stream of hydrogen atoms turns into ionizing radiation that would slice through the ship's armor like paper, destroying your cells and your DNA in a matter of seconds. And that's considering just the gas. What would happen if you hit a grain of dust? A single dust particle, the size of a grain of sand, colliding at nearly 300,000 kilometers per second, would release energy equivalent to the explosion of dozens of tons of TNT right on your vehicle. The impact would instantly vaporize the ship. At that speed, space doesn't feel like a vacuum. It behaves like a solid wall of lead and fire. But let's assume for a moment that you possess a magic ship, equipped with an indestructible shield capable of absorbing dust impacts and deflecting radiation. Let's suppose you can survive the trip. This is where Albert Einstein's theory of special relativity reveals the most terrifying effect of all: time dilation. Time is not a universal constant. There is no clock at the center of the universe ticking at the exact same rate for everywhere in the cosmos. It flows at different speeds depending on two factors: gravity and velocity. The faster you move through space, the slower you move through time compared to an observer at rest. Leave a comment if you'd like to see more catastrophic experiments related to time. At speeds close to the speed of light, time inside your ship slows down dramatically compared to the outside world. For you, your heart rate remains normal, and your watch ticks second by second. But for the rest of the universe, time has spiraled out of control. If you were traveling toward the center of the Milky Way, about 26,000 light years away, moving at 99.99999% of the speed of light, the journey for you inside the cabin would last just a few days or weeks. But when you looked outside and observed the galaxy, you would discover that while you experienced a few weeks, more than 26,000 years had passed on Earth. All of civilization as you knew it would be gone. The human species might have gone extinct or evolved into something unrecognizable. Traveling at the speed of light isn't just moving through space, it is a one-way time machine, a one-way trip to the distant future of the universe. At this point, the logical question is inevitable. Why does physics impose such a strict limit? The answer lies in the most famous equation in history, E equals mc squared. Mass and energy are two sides of the same coin. As you apply energy to an object to accelerate it, that energy doesn't just increase its speed, it also increases its relativistic mass. In our day-to-day lives with cars or airplanes, this effect is ridiculously small. But as you get closer to the speed of light, the mass of the ship starts to shoot up exponentially. To move a more massive ship, you need more energy. But that additional energy adds even more mass. If you tried to reach exactly 100% of the speed of light, your ship's mass would become infinite. And to accelerate an infinite mass, you would need an infinite amount of energy, more energy than exists in the entire universe. Only particles with no rest mass, like the photons that make up light, can travel at that speed. For any object made of matter, composed of atoms, reaching that limit is forbidden by the very fabric of the cosmos. But if for a moment we defied the known laws and managed to cross the absolute limit of the speed of light, the universe would break in the process. In Einstein's equations, the speed of light doesn't simply represent how fast a photon moves, but the cosmic limit at which information can travel. By exceeding this barrier, the mathematics require the time inside your ship to become a negative number. This is because in the equations, the time variable acquires an imaginary or negative value when speed exceeds that of light, which makes no sense at all. Imagine running for -3 minutes. One way to interpret this is to think you could go back in time. You would arrive at your destination before you even took off, breaking the causality of the universe and unleashing temporal paradoxes capable of destroying the very fabric of reality. The universe seems to have designed an impassable boundary. After all, the speed of light is an absolute limit that we can contemplate, but can never reach. Thanks for staying until the end of the video. If you enjoyed it, don't forget to subscribe, leave a like, and comment on what you think about this cosmic limit.